The way industrial inspections are done today is largely unchanged from how they were done decades ago. They're ascending to great heights, putting themselves in harm's way, and performing these inspections that are very manual and labor intensive.
10 workers were painting the bridge when their scaffolding collapsed.
A bridge inspector was killed when his snooper truck toppled over.
Nearly 2,000 feet up in the air, a contractor killed working on a TV tower.
The industry thought that drones would supplant these types of inspections, but it turned out that they cannot do that because of the way that they move.
We're building a platform to help solve that problem, right? A drone that can perform up-close and touch-based inspections.
Astria solves some very specific problems that no one else has been able to break the code on how to solve yet.
It has a unique configuration to put the 5 to 10 pound payload out from away from the center of the drone. This allows it to interact with the asset while keeping the rotor safely away. It has a cyclorotor on the center. This is that rapid thrust vectoring propeller that can quickly change the direction of thrust to compensate for wind and precisely move without needing to lean the drone.
It does not need to pitch forward or roll right to move in X and Y, and it can achieve a precision up to centimeters.
It is positioned there precisely by unique sensors that can operate with or without GPS. We have the 2 key elements of our drone patented. The first is the cyclorotor. We also have a patent pending on the drone configuration. Those 2 patents in combination are something that is going to make any other competition have a hard time catching up. We've made a huge effort to make every single one of the components that we could made in the United States.
We are building a platform that's super flexible with swappable payloads. It enables us to go after different use cases, different applications, different market verticals.
The main cause of wind turbine blade failure is due to delamination of the blade, something that we can see with the active thermography sensor, but requires getting close to the blades. On power lines, we can get up close and put a new payload arm and install bird diverters to help prevent birds impacting power lines. On bridges, inspectors will take crack cards and manually put up a small ruler essentially to the crack and then write down in a notebook what the width of a crack is. We've made a new sensor that when we get it up close to the bridge, that can more precisely, more accurately characterize those cracks faster and keep a great record of it.
You know, we're going to start with the inspection market, which is itself a $200 billion market, but we can move into industrial maintenance, aerospace inspection, and even defense.
We can take our drones and do it more safely, much cheaper, much faster, much more thorough, reduce risk, increase profit.
Our company was founded by Air Force veterans, and so I think we have a deep sense of mission, but I also think we have the drive and discipline to execute on that mission. Our CEO, Dave, brings over 24 years of industry experience bringing technologies to market. Our lead engineer, Zach, my co-founder, is one of the world's leading authorities on cyclorotor technology. His PhD research was really groundbreaking and I think paved the way for cyclorotor technology to really be understood and applied in new and novel use cases. Prior to my time at Pitch Aeronautics, I served in the Air Force as an acquisition officer. I led engineering teams to develop and acquire and deploy cutting-edge technology for the Air Force.
That's translating into Pitch being a winning team. And you see the leadership and the technical expertise as that's rippling through this team and they're creating something from the ground up. It's a fun thing to be a part of.